Welcome to this video on the User Data Protocol or UDP. In this video, we will explore one of the key protocols on the Internet transport layers and see how it powers many of today's real-time applications. UDP is a connectionless, lightweight transport protocol that belongs to the TCP/IP suite. Unlike TCP, it focuses on delivering data quickly without establishing the connection between sender and the receiver. Because of this, UDP is often called an unreliable protocol, meaning there is no guarantee that data will arrive intact or in the correct order. UDP's simplicity comes from its design. It is connectionless, which means there is no need to set up or terminate a connection before sending data. This allows for fast, efficient communication. However, it is also unreliable, offering no built-in mechanism for checking if the data was delivered or handling errors. Unlike TCP, it does not perform congestion control and the data is sent as soon as it is available. User datagram in UDP is simply a small data packet sent over the internet without any connection setup. It is fast because it skips extra steps like error checking or making sure the data arrives in the correct order. However, this means it is not as reliable as other protocols like TCR. Some of the key points are it has a shorter header with the source, destination, and size and the actual data. It does not ensure the data will arrive or be correct, but it is very fast. It is perfect for things like video streaming, online gaming, and live charts, where the speed is more important than reliability. The UDP header is a simple fixed size part of a UDP packet that contains essential information for data transmission. It is only 8 bits, 8 bytes, 64 bits long, making it lightweight and fast. The commands of the UDP header are source port 16-bit. It identifies the port of the sending device. It is optional and may be set to 0 if not used. Destination port 16 bits. It identifies the port of the receiving device. This tells the receiving machine which application should handle the data. Length 16 bits. Specify the total length of the UDP packet, including the header and the data. Minimum value is 8 since the header itself is 8 bytes. Checksum used to detect errors in the header and data. It is optional in IP version 4 but mandatory in IP version 6. The source port and destination port tell the packet where it is coming from and where it is going. The length field show how big the packet is, and finally the checksum ensure that the data has not been corrupted during transmission. The UDP services listed above cover a wide range of network management, diagnostics, file transfer, and communication tasks. UDP is favored for this application because it is fast and lightweight, making it ideal for real-time services where low latency is more important than guaranteed delivery. These ports are associated with various UDP-based protocols that handle services like network diagnostics, echo, discord, simple file transfers, for example, TFTP, time synchronization, and domain name resolution. Some of these services are also used in network management and configuration. The UDP package involves five components. They are control block table, control block module, input module, output module, input queues. Control block table. UDP has a control block table to keep track of the open ports. Each entry in this table has a minimum of four fields: the state, which can be free or in use, the process ID, the port number, and the corresponding queue number. Input queues. Our UDP packages uses a set of input queues, one for each process. In this design, we do not use output queues. Control block module. The control block module is responsible for management of the control block table. When a process starts, it asks for the port number from the operating system. The operating system assigns well-known port numbers to the servers and port numbers to clients. The process passes the process ID and the port number to the control block module to create an entry in the table for the process. Input module receives a user datagram from the Internet Protocol. It searches the control block table to find an entry having the same port number as this user datagram. If the entry is found, the model uses the information in the entry to enqueue the data. Suppose if the entry is not found, it generates an ICMP message. Output model is responsible for creating and sending user datagrams. Why use UDP instead of TCP? UDP is widely used in applications where speed, low latency, and efficiency are important over reliability. Its simplicity makes it ideal for real-time data streaming, lightweight protocols, and network services that do not require the complexity of TCP. The speed, since the UDP is connectionless, there is no need to establish a connection before sending data. It is much faster. There is no waiting for acknowledgement or retransmissions, making it ideal for time-sensitive applications like gaming, streaming, and real-time communication. Low latency, the minimum overhead in UDP helps reduce latency, which is crucial for live data transmission like voice over IP and online gaming. UDP supports multicast and broadcast transmission, allowing one-to-many communication efficiently, such as in IPTV or network management. Many applications using UDP have small payloads that do not require the overhead of TCP's acknowledgement and flow control. UDP has several advantages that make it suitable for specific applications, particularly those requiring speed and efficiency over reliability. Here are the key advantages of using UDP. Low latency. UDP provides faster transmission of data because it does not establish a connection before sending data. This means there is no waiting for acknowledgement, leading to quicker communication. UDP has a simpler header structure compared to TCP, which has a more complex header due to its connection-oriented nature. UDP is a connectionless protocol, meaning it does not require a three-way handshake to establish a connection before transmitting data. This feature reduces the time taken to start communication, which is beneficial for applications requiring immediate data transfer. UDP supports multicast and broadcast transmission, allowing data to be sent multiple receptionists simultaneously. The design of UDP is a straightforward with the minimum protocol rules. This simplicity makes it easier to implement and reduce the complexity of network programming for developers. Due to its minimal overhead and connectionless nature, UDP is considered a lightweight protocol. The lightweight characteristics makes it suitable for resource-constrained devices and applications that require rapid data exchange. UDP has several disadvantages which are important to consider when deciding whether to use it for a particular application. UDP does not guarantee that packets will reach their destination. There is no acknowledgement mechanism to confirm receipt of packets. Packets sent via UDP may arrive out of order. UDP does not implement any sequencing mechanism, which can be problematic for applications that require ordered data. While UDP provides checksum for error detection, it does not offer error correction. If a packet is corrupted, it is discarded without any recovery mechanism. UDP does not implement flow control, which means it cannot manage the rate of data transmission based on the receiver's ability to process incoming packets. This can lead to network congestion and packet loss. UDP is more suitable for applications that can tolerate some level of data loss where low latency is more critical than reliability. For example, video streaming, online gaming. UDP does not include built-in security features. Applications using UDP often need to implement their own security measures such as encryption and authentications. Thank you for watching.